Welcome, everyone. Thank you for joining us today. I'm excited to kick off our presentation on AWS, Amazon Web Services. Today, we'll also be exploring how ComputEra fits into this picture. Over the next few slides, we'll cover the essentials of AWS, discuss our partnership with ComputEra, and look at how these technologies can benefit your organization. Let's get started. Welcome to today's discussion on cloud computing. So, what exactly is cloud computing? Well, it's essentially the delivery of various computing services over the internet, which we often refer to as the cloud. These services include everything from servers and storage to databases, networking, software, analytics, and even intelligence. The key idea here is that these resources are provided on a pay-as-you-go basis, meaning you only pay for what you actually use. To put it simply, instead of owning and maintaining physical servers or software yourself, you rent them from cloud providers like AWS, Google Cloud, or Microsoft Azure. This setup allows you to access these resources online, anytime and from anywhere. The benefits are significant. You can easily scale your resources up or down depending on your needs, which is incredibly flexible. And of course, you pay only for what you use, much like electricity. No more, no less. Plus, it makes it possible to access your data and applications from virtually anywhere with an internet connection, which offers great convenience and mobility. Overall, cloud computing is transforming how we manage and deploy technology, making it more scalable, cost-effective, and accessible. It's a foundational concept that underpins many modern IT solutions and innovations. When we talk about cloud computing, think about services like Netflix or Gmail, which are prime examples of software as a service, or SaaS when you stream a show on Netflix or send an email through Gmail, you're actually using cloud-based services. Similarly, storing your files on Google Drive is another form of cloud computing. It's all about accessing your data from anywhere via the internet. Cloud computing isn't just about storage and streaming, though. It also includes data backup services like Dropbox and Google Drive that keep your information safe and accessible. Streaming platforms like Spotify are part of this ecosystem, providing music on demand. Communication tools such as Gmail and Microsoft Teams enable us to collaborate seamlessly. Beyond that, cloud computing supports e-commerce giants like Amazon, powering their online platforms, and it underpins advanced AI and machine learning applications that drive innovation. It's also important to understand that cloud computing comes in different service models: infrastructure as a service, platform as a service, and software as a service. Examples include AWS, Google Cloud, Salesforce, and Microsoft 365. Altogether, these examples show how cloud computing is integrated into many aspects of our digital lives, making services more accessible, scalable, and efficient. This interconnectedness is a core part of the overall technology landscape we're exploring today. Have you ever wondered how the term cloud in computing actually got its name? Well, just like natural clouds in the sky form when water vapor condenses around tiny particles, creating those fluffy shapes we see, the idea behind cloud computing uses a similar metaphor. Think of a cloud in the sky as a vast collection of moisture and gases that eventually results in rainfall. In the digital world, this translates to a huge pool of IT resources: servers, storage, networking hardware, and software platforms that come together to create a virtual infrastructure. These resources are delivered seamlessly over the internet, much like rain falling from a cloud. The beauty here is that you don't need to own or manage all this physical hardware yourself. Instead, you access it on demand whenever you need it. This makes cloud computing dynamic, scalable, and incredibly efficient, kind of like how clouds distribute water across the earth. So, just as clouds are a natural way to distribute water and moisture, cloud computing is a natural way to distribute IT resources, making technology more accessible and flexible for everyone. So why should we use cloud computing? Well, think of it like renting electricity instead of owning a generator. Imagine you need power for your home. You have two options: the old way, which is like on-premise solutions, where you buy a diesel generator, maintain it, refuel it, and handle all the repairs yourself. It's a lot of work and upfront costs. Or you could go the cloud way, simply plug into the power grid. You pay only for the electricity you use, and you can scale up or down whenever you need. Plus, the provider takes care of all the maintenance. Cloud computing works exactly the same way, but instead of electricity, what you're getting are services like servers. Think of Amazon Web Services or Azure, storage options like Google Drive or Dropbox, software applications such as Netflix or Zoom, and even advanced AI tools like ChatGPT or Gemini. The key benefit here is clear. There are no big upfront costs, no headaches over maintenance. It's all about instant, flexible access to what you need, whenever you need it, allowing you to focus on your core work without worrying about infrastructure. Let's delve into some key characteristics of cloud computing. First, on-demand computing resources mean that cloud providers offer IT resources like servers, storage, databases, and even software, all over the internet. And the best part is, you pay only for what you use, making it very cost-efficient. Next, scalability and flexibility are major advantages. Businesses can easily scale their resources up or down depending on their needs. This adaptability ensures they maintain optimal performance without overspending. Now, when we talk about service models, there are three main types to remember: IaaS, PaaS, and SaaS infrastructure as a service, or IaaS, provides virtualized computing resources. Think of platforms like AWS or Azure. Platform as a service, or PaaS, offers development platforms, such as Google App Engine, making it easier to build and deploy applications. And software as a service, or SaaS, delivers ready-to-use applications like Gmail or Salesforce directly to users, without the need to install or manage them locally. Finally, deployment models include public cloud, which shares resources across multiple users, private cloud, which is dedicated infrastructure for a single organization, and hybrid cloud, which combines both approaches for maximum flexibility. All these characteristics highlight how cloud computing offers scalable, flexible, and diverse solutions tailored to various business needs, making it a fundamental part of modern IT strategy. Now, let's look at some additional key characteristics of cloud computing that really highlight its value. First, it's cost-effective. By using cloud services, you can avoid the hefty upfront costs of hardware. Instead, you pay a subscription fee, which helps reduce your capital expenses and makes budgeting much easier. Next, reliability and security are major advantages. Cloud providers typically handle data backup and disaster recovery, so your information is protected and can be restored quickly if needed. They also implement advanced security measures to safeguard your data, giving you peace of mind that your information is safe. Then, there's the aspect of global accessibility. One of the biggest perks is that cloud services can be accessed from anywhere with an internet connection. Whether your team is working remotely or across different countries, everyone can collaborate seamlessly. This flexibility supports modern work environments and helps organizations stay connected no matter where they are. Finally, automatic updates are a big plus. Cloud providers manage software updates, security patches, and maintenance tasks behind the scenes. This means your team doesn't have to worry about manually installing updates or dealing with security vulnerabilities, allowing your IT resources to focus on more strategic initiatives. Overall, these features make cloud computing not just a technological shift, but a strategic advantage for modern organizations. Let's take a closer look at some additional characteristics of cloud computing. First, virtualization technology. This is the backbone of cloud infrastructure. It allows us to run multiple virtual machines on a single physical server, which really helps optimize resource usage. Instead of dedicating hardware to specific tasks, virtualization makes everything more flexible and efficient. Next, we have serverless computing. This is a newer approach where developers can focus on writing code without worrying about managing servers. Platforms like AWS Lambda or Azure Functions handle the infrastructure for us. And what's great is that you only pay for the actual execution time of your code, making it cost-effective and scalable. Moving on, cloud platforms also support big data and analytics. They provide powerful tools for processing and analyzing large datasets. For example, Google BigQuery or AWS Redshift are designed to handle huge volumes of data quickly, helping organizations make data-driven decisions more effectively. Finally, some cloud services are extending into edge computing. This means bringing computation closer to the data sources, like IoT devices, rather than relying solely on centralized data centers. This reduces latency and speeds up processing, which is crucial for real-time applications. All of these features, virtualization, serverless computing, big data support, and edge integration, highlight how cloud computing is continuously evolving to meet diverse and demanding needs, making it a foundational technology for modern digital transformation. Now, let's talk about some additional characteristics of cloud computing that really highlight its advantages. First, we have multi-tenancy. This means that the cloud infrastructure is shared among multiple users, or tenants. What's great about this is that it significantly improves cost efficiency because resources are pooled and utilized more effectively. At the same time, security isolation is maintained, so each tenant's data stays protected and separate from others. Next, we have green computing. Cloud providers are actively working to optimize energy usage in their data centers. This effort helps reduce the overall carbon footprint compared to traditional on-premise setups. It's an important step toward making technology more sustainable and environmentally friendly. Moving on, disaster recovery and backup are crucial features. Cloud services automate backups and use geo-redundant storage, meaning your data is stored in multiple locations around the world. This setup ensures that, even in the case of hardware failures or cyber attacks, your business can quickly recover and continue operating without significant downtime. Finally, we have API-driven development. Cloud services provide application programming interfaces, or APIs, which allow different applications to connect and work together seamlessly. This makes automation much easier and enables the creation of custom workflows tailored to specific business needs. All these characteristics, multi-tenancy, green computing, disaster recovery, and API-driven development, really showcase how cloud computing is designed to be efficient, secure, sustainable, and flexible, aligning perfectly with the overall theme of modern digital transformation. Let's take a closer look at the top game players in cloud computing. Starting with AWS, which launched back in 2006, it quickly became a leader due to its early entry and vast infrastructure. Then we have Microsoft Azure, introduced in 2010, which gained significant traction thanks to Microsoft's existing enterprise presence. Google Cloud Platform, or GCP, came onto the scene in November 2011, offering strong data and machine learning capabilities. Alibaba Cloud, founded in 2009, is particularly dominant in Asia, expanding rapidly worldwide. Oracle entered the cloud scene in October 2016, leveraging its strong database and enterprise software background. VMware, known for virtualization, has been involved in cloud services, often bridging home and work environments. IBM, which has been around since 2011 in cloud services, emphasizes hybrid and enterprise solutions. Lastly, Fujitsu, active around 2009 to 2010, has contributed notably to cloud infrastructure, especially in Japan and Asia. All of these players highlight the competitive and rapidly evolving nature of cloud computing. Each has carved out its niche, and together, they shape the global landscape we see today. This diverse ecosystem underscores how cloud services have become essential for businesses worldwide, aligning with our overall theme of digital transformation and innovation. So, for our next lecture, we'll be diving into the global certification path and exploring the services in cloud deployment models. This is a crucial area because it ties together the certification standards across different regions and how various cloud deployment options impact service delivery. We'll look at how global certifications help ensure consistency and trust in cloud services worldwide. Additionally, We'll examine the different deployment models, public, private, hybrid, and discuss how each influences the types of services offered, their security considerations, and their scalability. Understanding these concepts is key to grasping how cloud solutions are tailored to meet diverse business needs across different environments. This will build on everything we've covered so far about cloud infrastructure and security, giving you a comprehensive view of the landscape.